Good morning to everyone, or good afternoon, or good evening, wherever you are in the world. If you're enjoying this virtually, uh, hello. Thanks to everyone in the room for coming. My name is Allan Hirt, and for the next 50 minutes, I'm going to talk to you about business continuity, both hybrid and cloud native business SQL Server deployment. Now, what do I mean by cloud native? We'll get into that. Quick bit about me, not going to spend a lot of time on this. Been working with the SQL Server availability technologies for roughly 25 years, with SQL Server for close to 30. I switched jobs recently. I'm currently a technical evangelist for Pure Storage, but that doesn't change who I am and what I do. Dual Microsoft MVP, both in the SQL Server and Windows categories, as well as a VMware vExpert. So prior to joining Pure, literally my job was to help customers implement all the stuff that I'm going to talk to you about today. I'm going to show this slide again really quickly at the end, but I'll just say this is like one of the first days of the conference, but we all as speakers appreciate feedback and we hope it's constructive. So please fill out your feedback forms, and the only way we as speakers can improve. If you want to download the slide deck for this, you can download it from that link, and I'll leave this up here for a second so people can capture that. Okay, moving on. All right, so let's level set before I get into any of the technology pieces. When I think about just the term high availability, how I define it is I can recover from a fairly local/small kind of event that takes me out. And this could also be something planned as well, like I'm doing maintenance on my servers, and I want to be able to just quickly switch and be online instead of being down during the whole maintenance window. But bottom line is, this one, in the grand scheme of disasters or anything planned, is not that bad. Then we have disaster recovery. Disaster recovery to me is basically your data center or, say, a region in the cloud is a smoking hole in the ground, unavailable for whatever reason. This is a more serious thing. Obviously, there might be something catastrophic happened in the region where people would be affected as well. But what this also means is that this is more than just a database failure or a SQL Server failure. This is something more catastrophic, and there would be, say, core infrastructure that would need to be up and running long before you would even think about getting SQL Server up. So there'd be very much an order that things would need to get up and running. So for me, this is a much more coordinated, much more time-intensive event. But the real reality of what we're doing is business continuity. I try not to talk about just HA or DR these days, because the whole goal of those two things, HA and DR, are to keep the business up and running. And everything we do as technologists supports that. It's not because we like implementing cool technology, although that may be true. It's really about everything other than technology. Technology is just the end implementation of this from an IT standpoint. The other thing on this that I really quickly want to talk about, because this is something I saw with a lot of customers over the years. Many customers will build into their initial stuff the availability in their local data centers. Or like if you're doing stuff up in the cloud, they'll go, hey, we just want to be able to fail over. The problem is they go, whether it's budgetary reasons or for anything else, they'll say, well, disaster recovery, we're not going to worry about that. We've never really had an issue. We'll deal with it later. The problem with that is, with a lot of these features that I'm going to talk to you about today, or just in general, sometimes it's hard to bolt on disaster recovery later on. You really want to think about disaster recovery when you are first implementing. Because if you have to do it later, you might have to either work around stuff or completely implement a new solution. And that's really not what you want to do. You should think about business continuity in total from the start. As data professionals, there are really two things that we care about the most when it comes to business continuity. The first is recovery time objective. Simply put, that's how long you have to be up and running after an event, something happens. So in this case, what you need to think about is forget skills or what you can do. What does the business require, right? Then the other things like skills and everything else comes in, because if the business wants you to be up and running in, let's say, 5 minutes, but it's going to take you longer than that just to get in front of a keyboard, a 5-minute RTO is not going to work. So paper RTOs, never good. The other thing about RTOs is that you really need to negotiate them, and they need to be different for both local problems as well as disaster recovery. So as I said, if we're recovering or dealing with something more in a localized type of event, then maybe we could be up in a couple of minutes. But if our data center is that smoking hole in the ground and we're coordinating resources and making sure the networking and storage and Active Directory is up, that may take a long time before they even say, okay, database professionals, it's your turn, right? So having an RTO for disaster recovery that's realistic needs to happen. And that's, again, something that's negotiated with the business. The other thing that happens there that you have to take into account is things like, as I sort of mentioned, skills. Because if you have people who aren't experienced doing this and you haven't tested anything, so at least people are comfortable with it, mistakes could happen, things take longer. Other things factor in, like, for example, have you tested your backups? How long does it take to get your backups? All that factors into how long it's going to take you with RTO. RPO is the more important one from a technology standpoint. So think of the RTO as the people and business one. RPO is more of a business/technology one. Simply put, RPO, or recovery point objective, is the point to which the data has to be recovered. If you talk to any business, they're going to say, hey, we want 0 data loss. Well, that may be true technically from a SQL Server perspective, but how they define data loss might be different than how SQL Server defines data loss. And you need to have conversations with the business folks to make them understand. For example, if your SQL Server has to go through a stop and a start, such as a failover cluster instance failover, or even a standalone that goes through a stop and a start, that SQL Server recovery mechanism is going to kick in, which means you'll be consistent to the point of when it stopped and started. If you have an availability group failover, depending on where you're at from a synchronization and if you've done a force failover, if it wasn't synchronized, your data is going to be close-ish, or it will be at the point of failover when you did the failover if it was synchronous. So you'll have to do some checking to see what that is. So from from a SQL Server standpoint, that's technically no data loss because SQL Server is taking care of itself. Now, people sitting on the other end of a screen who hit OK or save or submit in an application may not think that's not data loss if their transaction didn't get processed, or something didn't happen. So you need to understand what the business is thinking, but you need to explain to them how the technology works, and then come up with a realistic goal. Because from my standpoint, RPO, is more like, okay, if we were a smoking hole in the ground, we want to be able to recover within 15 minutes of when that failure was, even if that's just from backup. But again, those are things you talk about with the business, negotiate, and make sure that you have these things done and in place before you even think about implementing any technological solution. Because a big part of defining these is what are you going to be measured against when something happens? Because how do you measure success if you don't have these metrics? And because the other part about this too, to be honest with you, is I've been in situations where a C-level is standing over your shoulder, waiting for something to come up. And if you technically have negotiated a 2-hour RTO, they can stand over your shoulder all you want. In theory, they can't bother you until 1 minute after 2 hours is done. That's not reality, but at least you've negotiated something and you have a time window. You might need to renegotiate them as, for example, data sets change. If your data grows exponentially, what worked as, say, a 2-hour window may no longer work if your data grew. So think about that as well. Okay. The most fundamental thing before we talk about any features in SQL Server is backup and a restore/recovery, however you want to define that, strategy. Because in my mind, when we're thinking especially the disaster recovery part of business continuity, it's worst case scenario. You hope that your features work. You hope whether you've implemented log shipping or an AG or an FCI, that it just works and things come up and SQL Server is honky-dory. Unfortunately, that's not always the case. For whatever reason, sometimes those things actually can fail. So at that point, what are you left with? You're left with some form of basic backup and restore. So number one, make sure you're doing backup, because I've still heard things to this day, no matter how long I've been using SQL Server and helping people with it, that I have insert name of feature here, such as an AG, and I don't need backups because that's my availability strategy. I hope you have your resume together, because that's a nice resume generating event. Or CV, sorry. I'm in Europe, in the UK. The reality is that features are nice, but this is the fundamental building block of business continuity, period. So, it's not enough just to generate backups. If you just generate a backup, it's a file on a file system. That's it. You need to test your backups. So here's the thing. I understand most people out there don't have just a single SQL Server installation with a single database. That would make that super easy. Most people who are administering or managing SQL Server or any database for that matter usually have lots of installations, not just production, but oftentimes development, test, staging, and in production you may have hundreds or thousands of databases or instances of SQL Server. So I'm not one of these people who's going to say you need to test everything, because that's honestly, I know that's unrealistic. I've worked with customers. But at the same time, you know the top 1% or top 1 or top 5 or top 10 applications in your company or with your customers that if they go south, they're going to be screaming about. Those are the ones that should get the priority in the testing. If the data sets are too big, find a way, but do it occasionally. Point is, going back to the RTO for a second, and RPO, but especially the RTO part of it, one part of that negotiation is if you've actually tested your backups with, even if it's on different hardware, if it's on a virtual instead of a physical, because that's what's in production, you'll know how long that took. So if, let's say you did it on slower configuration and it took 2.5 hours to get back up and running from backups. During either your negotiation or when the C-level is over your shoulders, like, hey, we restored this database a couple weeks ago. It took about 2.5 hours. This hardware that we're working on now, it's a little quicker. We're hoping it's quicker than 2.5 hours, but we've tested it. That gives them confidence that you know what you're doing. The 3 words that you should never say to a C-level in some sort of business continuity event is, I don't know, when it comes to things like this. Because it will, to a degree, demolish any confidence they have in you. Because the more you test things, the more you have confidence in your own solutions, and that comes through to them. So just be really careful here. The other part about this is if you're using third-party applications, and I'm talking about your Veeams, your Rubrics, that kind of stuff of the world to handle your backup, are the people who are responsible for that system also on the hook when these things happen? If you've answered no, or you're shaking your head, or you smiled in the room, chances are I hit a nerve. And that's the problem, because at the end of the day, you guys are going to be the DBAs, the default blame acceptors for problems in SQL Server. And if you're reliant on someone else to get these backups, and they're not on call at 2 a.m. when somebody updated the schema in the database for the application and it went awry, what's the process for that? And what if they are not online for another 8 hours and somebody's screaming at you? This is one of the reasons I like to have native backups if possible. if they're reasonably local, you can get that done. And then they can use whatever process to get that over to their back-end systems. I'm not saying to never use those systems or never use them to back up SQL Server. But again, you know some of the systems that people are going to scream about. And if it takes you a long time to get those backups, that's a problem. Okay. Thinking about SQL Server for a moment here. Here's how I kind of break down how I think about protecting SQL Server. There are 3 layers. There's instance level, meaning you're protecting everything that's installed with the instance inside. So logins, jobs, linked server, you name it. And there's one feature in SQL Server that handles that. That's an always-on failover cluster instance, or FCI. That's the form of clustering that's been in SQL Server since 6.5. So it's been around a long time. It's tried and true. There are reasons why you may or may not want to do that in modern topologies, and we'll talk about some of that coming up. There's database level. So the features there I think of are always-on availability groups and log shipping. The reason I have database mirroring on there is because technically it's one. It's been deprecated since SQL Server 2012. Please do not use database mirroring. It was technically replaced with availability groups in SQL Server 2016, which was given a formal name called Basic Availability Groups. I hate that name. Just call it Availability Groups in Standard, because that's exactly what it is, just a limited version of, just like FCIs are a limited version in Standard, and that's it, right? It's not some different feature, because I get that question a lot. They think it's something other than an availability group. No, it's just availability group that's limited. So the problem, and I use that in quotes, problem with a database level feature is that with things like instance level logins and linked servers and things like that, it doesn't account for that, because the database level features are generally based on the transactions that come to the transaction log. So, and then the synchronization process that happens as part of those features is an automatic thing. That's awesome. But if you actually have to use another server or another instance of SQL Server as your new primary, so for example, if you do an availability group failover and need to bring a secondary replica up, does it have all the stuff it needs to have to be that new primary? Right now, you've got to figure out how to do that. There are lots of ways to achieve that. It's not like it was 10 years ago. Microsoft has some scripts. You can use DBA tools. There's a whole mess of things. You can do it manually yourself. None of this stuff, but you have to put that elbow grease in. There's one exception in SQL Server 22 in Enterprise Edition now. It's contained availability. It's a form of availability group called a contained availability group. I've got a couple blog posts on it on my site, so you can go learn more about that. But bottom line is, outside of that, you've got to handle this on your own. And just part of the process, it's not a big deal, but you have to think about that, because again, in a business continuity thing, if the other replica is for availability, you're going to want to use it and have people connect to it. Finally, there's a data level. The thing I'll throw in here as the feature is replication. And I'm very careful not to use the word replication other than to refer to the feature, because a lot of people will use the word replication with availability groups, and that's not really what it's happening. You're synchronizing. Replication to me is the feature in SQL Server, and there are 3 forms of it. But the reason I put it up here in the availability space is that it can be used to make data available elsewhere. For example, your C-level on every Monday morning or every morning needs to run a certain report. The rest of the infrastructure could be just steaming. But if they can get that report, they're probably not going to be that concerned about anything else. I say that kind of jokingly, but it might be also kind of true. The other thing about replication, which is very different than the other 2, is that the database is live on the other side. So you can have different indexes, different schemas. It can be a subset of data. It doesn't need to be the whole set of data. So it's one of those things where replication has its place in the availability topology, but I would never, ever use it as my primary form of availability. I get that back in the old SQL Server 4.2.1 days, the very beginnings of SQL Server, from Microsoft, that there really weren't any features besides that, and that's why people think of replication to a degree these days as an availability feature. But it's really not. We have true availability features that cover what we need. So if you're using replication as your primary form of availability, you've got to really think about that. It also suffers from the same problems as the database level stuff does. It doesn't deal with any objects outside of the database or anything that you've synchronized over. So, you have lots of ways built into SQL Server to handle things. We'll talk about a little bit later in the talk about other potential features you could use, but that sit outside of SQL Server. But right now, we're going to focus on these. Okay. From a cloud perspective, when you're deploying your IaaS VMs, so specifically, let me take a half step back. In the cloud, you basically have two types of deployments when we're talking about database level stuff. You can have an IaaS or an infrastructure as a service virtual machine, which has an OS and obviously at some point an installation of SQL Server. And that OS could be Linux or Windows. Or you have platform as a service or PaaS. Think Azure SQL MI or Managed Instance or Azure SQL Database. On those, you don't have an OS. It's not SQL Server in the traditional way we know it. And basically, all the business continuity, availability stuff is essentially done for you, or you click a couple buttons and it's done for you. You don't have choice of what we just talked about. Everything I'm talking to you about here pretty much is all on the IaaS side of the house. And anything I'll reference with AWS, similar thing. I'm not talking about Amazon RDS. I'm talking about their instances is what they call their virtual machines. But up in Azure, what we have is when you deploy your VMs, you have availability sets, the options of availability sets and availability zone. Sometimes both are available to you, sometimes one or the other. Microsoft varies from region to region. Simply put, a zone is where basically everything's kind of in a different data center. So there will be a little bit of latency, but it's within the same, essentially, geographical distance. From an availability set, those were added later, actually. Initially, we just pretty much had availability sets, which is ensure that if you're doing maintenance, that you don't stick these VMs in the same rack, essentially. So if they're doing top of rack stuff, like you're not going to be affected, like both of your VMs and availability group are not going to be affected. So the good news is you can just build into the architecture of the VM you deploy some separation. This is not unlike anti-affinity in virtualization on premises. The problem that you have here, much like a lot of things, is this is not a bolt-on thing. This is something that needs to be decided up front when you deploy your VM up in Azure. So if you're already running up in Azure and you want to use this, you're going to have to redeploy in a new VM and migrate stuff to it. There's no way I know of switching this on behind the scenes. There's no PowerShell or Bash that just adds it after. So if you're doing new greenfield deployments of SQL Server up in Azure, especially if you're doing availability configurations, I highly recommend that you look at doing this stuff. Okay. Now, AWS and GCP also have similar concepts. That's a picture from some of the AWS documentation where you were basically there. The way to do it is split things out over zones. They don't have the concept of availability set. The one thing that's more challenging for me in AWS is the networking piece, and specifically, every zone, even if it's in the same region, has a different IP address. So you're going to get into a lot of multi-subnet scenarios when you're wanting to have things done properly. And so you need to make friends with your networking folks, if you're not already. But if they hate you, I don't know, buy them some beer or whatever they like and take them out to lunch. But networking becomes a huge thing here because if you don't get that right, your availability groups probably aren't going to work correctly. Especially if you want things like automatic failover within a region, like in an availability group. I'm not talking failover, say, between say US East and US West because I'm in the US, but like within like US East 1, if you want just automatic failover, yeah, you need to get this stuff working. So, but again, these are things that you need to think about at deployment time. This isn't just like, oh, we'll kind of move it later. You really should get this stuff right from the get-go. Okay, so first of all, one of the biggest gating things of anything in any of the public clouds, Azure, AWS, GCP, is performance. I spent a lot of time in my training day yesterday talking about this, and we only have limited time, so I'm not going to really dive too deep. But this is what I want you to understand. When you select a IaaS VM size in any of the public clouds, you get limits. It limits the amount of network bandwidth, the amount of IOPS. Forget CPU and memory for a second, because that's not what I care about necessarily with, say, an availability group. But if your IOPS are pegged because of your VM size, then you may have for example, if you want to have a synchronous availability group, but your performance is terrible, you're going to be in a synchronous mode, but it might not be synchronizing in the way that you want to. You might be not in a synchronized ED state. So that means you may need to resize your VM, which means downtime, to be bigger to have higher IOPS or network bandwidth limit. Because I've seen, for example, customers who underpower their DR stuff because it's cheaper, right? They go, well, it's just DR, so we'll underpower it. But let's say you issue a clustered index rebuild on a 3 terabyte table that needs to be synchronized. That's going to take a long time to do if you've underpowered that secondary replica in an AG. So maybe you resize it before you do that, and then you resize it again after. But understand that performance is going to be a gaining factor in the clouds more than you think, right? I understand that cost is a factor in the cloud. You know, OpEx is a real thing. People aren't looking to spend millions and millions and millions of pounds or dollars or euros a month on this stuff. But if you underpower things and you're not able to achieve your availability goals, then it doesn't work. So you have to find that balance. If you're deploying a Windows Server failover cluster, it always has to pass validation. Even if, for example, you're using one of the templates that are up on one of the clouds. So AWS, where I took this picture from, they have this like template to go create an availability group. I'm not telling you to use that template or not use that template. Personally, I would create it myself because I know what I'm doing, but if that makes it easier for you, awesome. However, I've never run that. I don't know if they actually run cluster validation. And to have a supported cluster from Microsoft perspective, validation needs to be run. Now, Microsoft now has a template up in Azure. It's not for all scenarios, but if it fits your scenario, it'll work, but I know it does run cluster validation. So it's the little subtle things, because a big part for me about these business continuity solutions is that they're supportable, not just internally and manageable that way, but they're supported. And that if you call a support organization, they're not going to give you what I call best effort support. They'll try and help you, and then at some point it's like, well, it's not technically a supported solution, so we've reached the end of our rope. Good luck. That is not what you want to hear in a server down situation. Trust me on that. Another problem with availability groups up in the cloud especially is, let's say you want to use a hybrid scenario. Now, hybrid is where you've got your on-premises stuff, and let's say that's your main, but you want to do, let's say, DR in the cloud. If you've got a very large database, how are you initializing a secondary replica up in the cloud? Because that backup or that copy of a backup or however you're going to do the synchronization is going to take forever. And that, again, goes back to a cost thing of, let's say you're using Direct Connect or Express Route or one of the direct connections from on-premises to the public cloud provider. It's faster than a site-to-site VPN, but it's still not necessarily going to be the same speed as your on-premises network. So you have to plan for that. It may take you the better part of a week if your pipe is slow to copy up a multi-terabyte backup. Because you got to remember, it's not just you using that pipe, it's other stuff using that pipe too. I think that's the part of the equation that's lost in some of this. If you were the only one using the pipe, it might go quicker. So I've done this with customers a lot, and we had to do a lot of pre-planning of, okay, when do we take the backup, move the backup, how long is it going to take to copy, how long is it going to take to restore? So to get that secondary replica up end to end might take a week or two by the time you get it, copy it to where it needs to go, and then restore it. So plan for that in your architecture. It's not something that you can really just say, oh, by the way, because what I've seen in a lot of organizations is they want it to set it up like tomorrow, and they're not taking into account things like data size and their speed of their network and all the other good stuff, the intangibles that to a degree don't matter to SQL Server or the process, because that is what it is, but it has everything to do with SQL Server and the process. Okay. So consider another big consideration is where am I putting basically my witness resource for my cluster? If you're using Azure or you're doing some sort of hybrid up to Azure, I just highly recommend using Cloud Witness. It just makes life so much easier. You don't have to worry about like an independent third site where you have to put a file share witness or something. Now, some larger companies have multiple data centers beyond 2, but most smaller companies sometimes just have 1. So, but if you have more than 2, you can use one of your own data centers and do something like a file share witness. If you're doing, let's say, an FCI, even up in the cloud, I still kind of recommend Cloud Witness because it's easier. You could do a disk-based one. That's generally the rule of thumb when you have shared disk. However, if you're in, let's say, AWS, sure, you could use Cloud Witness, but are you going to, if you're solely in AWS, are you going to create a whole, Azure account just to put Cloud Witness? Probably not. But so what that means is you're going to have something like a file share witness in a different zone in the same region. So in one of my demos, which I'm not sure we're going to have time to look at, I have an availability group where I have one replica in zone 1, one replica in zone 2, and the file share witness in zone 3. So that way I have geographical separation between my core components of my cluster. I'm not saying that you're going to do that or that you should do that, but that gives me a little more peace of mind. One of the problems that we have with standard edition of SQL Server, specifically when it relates to how it's configured, is that you're limited to 2 replicas. So if we're talking about business continuity, let's talk about hybrid for a second. OP stands for on-premises, C stands for cloud. This is basically what you would have. You would have one replica synchronizing with something in the cloud. So we're probably talking multi-subnet, the whole deal. That's not the problem I have. My problem with this is you have no local availability. You have disaster recovery here. So the only real way around this is locally to implement an FCI. So you have local failover and then have the AG spanning from the FCI to like a standalone or potentially an FCI up in the cloud. That's really the only way to get that with standard edition. And it's unfortunate, but my hope is that Microsoft at some point gives you at least 3 replicas in standard edition. That would make this scenario so much easier. But here's the reality of what we have in standard edition. And having worked with customers for a long time, I know not everybody buys enterprise, which is why I talk about standard. Another thing you'll want to consider potentially, and I have a link there. It's sorry about that. Go back here. If you're spanning multiple sites And that could be different regions in Azure. It could be on-premises to Azure, on-premises to AWS. It could be AWS to Azure. You might want to consider configuring site awareness in your Windows Server failover cluster. That link I have right there is to some Microsoft documentation on what that is. So I'm not spending a whole lot of time. You can read up on that. But basically, you configure the cluster, and you tell it, hey, I would prefer, for example, resources to run on this site. Now, in general, though, let me rule of thumb. Please do not configure automatic failover between two different sites, because the chances of you staying synchronous between and synchronized between two long distances is pretty small, unless you spend a metric crap ton of money on your network. And even then, the way I think about this, to be honest with you, is really simple. If I'm switching data centers or regions in Azure or AWS or GCP, or from on-premises to Azure, that generally means I had a much more catastrophic failure, so it's DR, and that's a more, like I said, a more measured thing that's got to happen. So I don't want my SQL Server stuff to automatically fail over or try to fail over somewhere else in that case. Locally, I might not care, but if I'm spanning that much distance, I want a little more control over that. Oh, already talked about that. So shared storage is a bit of a pain. You can use Azure Shared Disk up in Azure. I didn't put it on the slide, but there's a shared option in AWS. You can use iSCSI, you can use Sios Data Keeper, but understand that up in the public clouds, there's no perfect way to do this. You have options. It's a matter of what makes the most sense to you if you're going to do an FCI up in the cloud. Would I recommend that in general? It depends. I've done it for customers. Sometimes it actually does make sense. A lot of times it's driven by applications that only support FCIs and not AGs. But again, that's a different issue. That's outside the scope of this particular talk. Okay. Here's actually a big one. So if we're talking, you're using a Windows Server failover cluster and you're not using Linux and Pacemaker. One of the problems, and I ran into this a lot with customers, is that all right, quick show of hands here. How many people use Windows Server failover clusters and understand what the core cluster group is in the room? I had one person. Okay. Let me explain this really quickly. Actually, let me show it to you, because I do. I can show it in numerous places. This is Azure. Forget about the server. Okay, right down here, these core cluster resources. First of all, this is Azure, so there's what your cloud witness looks like. Has a cute little picture of a cloud. But basically, and that distributed server name, that's known as a distributed network name. We'll talk about that next, so get to that in a moment. But basically, these core cluster resources, this is essentially the brains of the operation, if you will. This is always owned by one node of the cluster, and it doesn't need to be the node that owns the AG or the FCI. Let me be clear about that. However, the problem is that in a situation where you're not using a disk-based witness which keeps a copy of the latest cluster configuration, also known as a cluster database, the other ones basically rely on the node that has the core cluster resources to be the master one, and then it propagates out changes. If a node doesn't have the latest changes and you try to fail over to it, you'll see an error that basically says, hey, this node doesn't have the latest configuration of the cluster. That condition is known as partition in time, okay? And you could force the cluster up. There are things you could do, but bottom line is it's just something you need to think about. But the way to sort of deal with this on some level is, as part of your standard monitoring, understand which node or which side has the core cluster resources. Because let's just say your primary site, let's say you're hybrid, okay? And your primary site is on-premises. Actually, let's use the whiteboard picture real quick, because it would apply to this scenario. This wouldn't necessarily be all the same cluster, but actually, let me get rid of the FCI. Assume this is Enterprise Edition now. We upgraded. Here, on-premises is your main thing. You want it basically to stay here, and then going up to the cloud would be a, hey, if we're really in a bad situation, I want to go there. Okay, thank you. Sorry, there's a question. I'll get to it in a second. So let's say your core cluster resources right now are owned here. If you lose your network between on-premises and one of the clouds, potentially your cluster will go down because the brains of the operation can't see the other nodes, and you might lose quorum, because quorum is all about the number of votes. So what you have to try and ensure is that this, if this works, stays where your main stuff is running. So if my AG is on premises, just keep checking that the core cluster resources are there. That's part of site awareness to a degree, is you can kind of say, again, try and keep things here. But at the same time, if you're doing a controlled failover, you may want to fail this over here and then move your AG so that everything's, again, same location. This is like one of those things that you don't think about until you try and bring stuff up in a bad scenario, and you're wondering why things aren't coming up cleanly or as easy as you want. It's because the core cluster resources are a big part of what's going on underneath the covers. So just, again, something to consider in all your things is having to deal with clustering. So this is what they look like. Now, underneath the covers, just so I'll show you real quick. So, look, would he be mad at me right now? He's not a fan of typing demos. All right, you see that cluster group right there? That's the core cluster resources. So if I do this, oh, I actually specify the role, sorry. That up. So you can see those are those two resources that map back to what we see over here. So if you're doing any kind of scripting, that's what you're looking for. You're looking for cluster group. Don't get me started on why they call it roles in the GUI versus, yeah. But that's what you need to be looking for. Okay. So I've got how many more slides I've got? Okay, let me answer the question real quick. Oh, question went away? Or it is not. Okay. Okay. So clusterless AGs, simply put, they're not supported for availability configurations. The question was about, I talked about cluster validation. What about for clusterless AGs? You can't be using them for an availability configuration. So simply put, it's a side effect. So clusterless AGs, and they're not actually really called that, so I wish people would stop. What it is you can create an availability group with a cluster type of none. And the official name is called a read scale group. They're actually meant mainly to scale out your read. Now, it's to a degree a side effect of how they implemented SQL Server and Linux. It just happens to work on Windows that way. So you can create, an availability group that doesn't need an underlying Windows Server failover cluster. Now, there's no cluster mechanism, so there's no automatic failover. and there's nothing like that. So that's why it's not an availability configuration. Now, I put an asterisk next to that a little bit because you can technically use it if you're setting up some sort of weird DR scenario. And there are a couple of those I'm not going to get into here, but as a general everyday availability scenario, set up a cluster. And it's actually in Microsoft documentation as that. So if you're doing that today, stop, go create a cluster. Okay. Now, you saw in my demo there real quick that distributed server name. That's the formal name is a distributed network name, or DNN. Simply put, it's a different way so that you don't have to do some of the Active Directory stuff that you do, or actually not so much that. If you create a listener or an FCI in the cloud, in Azure specifically, but until the DNN, what you had to create was a load balancer so that when you failed over, let's say the FCI from node 1 to node 2, or the AG, and then obviously it's listener from node 1 to node 2, that other things could see it. And you created an ILB, you created a probe port, you assigned it to basically the listener resources and made all the magic happen. It's just the way networking works in Azure. It's not a SQL Server thing. To basically get rid of the ILB, there's a distributed network name. The problem with the distributed network name is it doesn't work with distributed availability groups. It doesn't work in a multi-subnet scenario, but it does get rid of the ILB. So if you're in basically a single region, single subnet kind of a thing, the DNN might be fine. Now, I'm specifically talking about the SQL Server layer, not the Windows Server failover cluster. It doesn't matter to SQL Server what's sort of happening at the Windows layer that way, the core cluster stuff. I'm talking more about listeners and FCI. Going to put this here real quick, but if you have to create if you don't want to use the DNN, you have to do something like that. It's PowerShell, because if you use the GUI to create the Windows Server failover cluster, by default, in later versions of Windows, it's going to create a DNN. If you don't want a DNN in Windows, you've got to use PowerShell. Okay. I've only got a couple minutes here, so try and squeeze all this in. First of all, this is probably the most important slide, but it's sort of self-explanatory. If your networking isn't working, none of this works. Clusters are sensitive beasts. I've had customers where things have happened on the back end of Azure that it affected their availability group, so we've had to adjust the thresholds. Again, that's a link to some Microsoft documentation there for you that talks about how to adjust some of the networking thresholds in the clusters so that things are more tolerant. But understand that if you're doing that, it means that some of your detection for actual failures might take just a touch longer. But if you're doing it because of tolerances of your own on-premises network or up in one of the clouds, it's okay. Just understand the trade-off you're making there. I just talked about the ILB, but the big thing about the ILB is making sure you configure it correctly. Like I said, put the probe port inside and make sure everything else is set right. There's documentation on Microsoft's site for that. Similar to the thresholds, there are two settings that are very germane to specifically more listeners than anything else. It's register all providers IP and host record TTL. Simply put, Microsoft recommends you setting host record TTL for your cluster resources for SQL Server to be 300 seconds or less. The default is 1200 or 20 minutes. The culprit ties right into DNS because simply put there, if you have a 5-minute RTO but it takes 20 minutes for your DNS to propagate, you've missed your RTO. So cranking down things to meet your RTOs has to happen. Register all providers IP really quickly. Set to 1, which is the default if you're in a multi-subnet scenario where you have more than one IP address associated with your FCI or AG. It means that if you allow dynamic updates to your DNS, it's going to put both IP addresses in there. That may or may not be a problem in your environment, so talk to the folks who own networking and DNS. And if you do not want both IP addresses in there, you have to set that to register all providers equals 0. Or if you manually deal with your DNS, that's a separate issue. Every time you have a failover, you're going to have somebody update the back end. So with that, we're at time, but I just want to talk to you, go over for 1 minute here. So we have this. If we're spanning multiple sites, you have a single availability group. Your challenge here is basically your cluster piece, making sure it's fully available. If you have Enterprise Edition of SQL Server, I recommend in these scenarios considering a distributed availability group, because you have 2 separate clusters and each one maintains its own quorum and synchronization. The P1 over there that you see, that's known as the global primary. It's the only read-write copy. Yes, the P2 is technically a primary, but it's known as the forwarder. So the P1 synchronizes S1 as well as P2, and P2 synchronizes the stuff on the other side. So again, there's plenty of documentation out there. I've got presentations. I think I've done some at Bit. You can look them up. And a quick mention, somebody's got to pay for this stuff. Licensing matters. Microsoft rules are very complicated. If you have questions, I will be down in the exhibitor area for the rest of Bits on and off, so feel free to catch me. Thank you so much for tuning in. If you're online, I'll stick around here for a couple minutes up here for questions. Have a great rest of SQL Bits, everyone.